All right, ladies and gentlemen, what we are going to be taking a look at in this particular lesson is we're expanding on what we were talking about as far as matrix operations are concerned. So what we've looked at in our previous lesson about matrix operations is we first identified how to identify if a matrix was equal to another matrix by saying that they had to be the same size and every element of one matrix had to match exactly to every element in the next matrix. And then we looked at how we added them together, and in order to add matrices together, we showed that first of all they had to be the same size, and then when we added them together, we added the corresponding elements together to produce a new matrix. Well, now what we're going to be getting into is multiplication of matrices. Multiplication of matrices, while multiplication itself, in normal arithmetic isn't necessarily that much harder than addition or subtraction is, in matrices it really does kind of become another order of magnitude almost as far as the amount of work associated with it in comparison to how we added matrices. It's not difficult or complicated per se, but there are a lot of little parts. Now, again, just like every other process in math, once you understand how the process works, then you stand a much better chance of performing the operations successfully. The issue that you are generally going to run into is, again, just basic arithmetic issues where you miss a sign somewhere, or when you multiplied a 2 and a 3 together, you wrote a 5 instead of a 6, or something like that, okay? So here what you're seeing, in order to multiply matrices, the number of rows of one matrix and the number of columns of another matrix have to match. Okay, so what it's telling you here, so M and N, those are just representing the number of rows and columns of one, and N and P are representing the number of rows and columns of a second matrix. So the way that we're going to kind of look at these is that when we put the sizes of the two matrices next to each other, as long as the number of columns in the first matrix matches the number of rows in the second matrix, that means we can multiply them together. If those numbers there where the two n's are different for some reason, like one's a 2 and one's a 3, it means we can't multiply them together. And the dimensions of the new matrix, how big the new matrix is, tells you how big the new matrix is. So the two numbers in the middle, that tells you if you can multiply them together, and the two numbers on the outside, that tells you the size of what your final matrix is going to be. And I'll kind of elaborate that on a little bit here. Now, up at the top, this by itself isn't necessarily something that you have to have in your notes, okay? So if you don't want to write this down, by all means, don't. It's not that important for what we're going to be doing. It's just that in math and algebra, there are certain properties for addition and multiplication. The associative property tells you how things are grouped when you add them together. And the commutative property talks about the order in which things are multiplied. All right, so the commutative property talks about how things are ordered in a problem. Okay, so let's just say normal arithmetic. If I say 3 times 2, I get a 6. If I say a 2 times a 3, I still get a 6. The order in which I multiply those numbers doesn't matter to the outcome. However, in matrices, if I say matrix A times matrix B, maybe that gives me a matrix that we'll call C. But if I say matrix B times matrix A, that's not really going to give me the same matrix that I would have gotten the other way around. Maybe that's going to give me some other matrix that we could call D. That's all the commutative property is saying, and it's really not that important. So again, if you don't want to write them down, that is, you're not going to hurt my feelings. But what I wanted to elaborate on a little bit was on the previous screen as far as the product of a matrix. Okay, so let's say I have matrix A, and let's say that that is a 3 by 2 matrix. And let's say I have matrix B, and let's say that that is a 2 by 3 matrix. Well, if I say matrix A times matrix B, the way that we're going to look at these, first of all, we're going to say, well, can we multiply them together? So what that previous screen said, well, we're going to look 3 times 2, and we're going to put 2 by 3. We're going to put the sizes of the matrices next to each other. Because these two numbers are the same, this says yes. We can multiply these two matrices to each other. Now, the 3's on the end says that the product of A and B will be a matrix that has a size of 3 by 3, and that's what I just wanted to put that there to elaborate a little bit more from what the previous slide was telling us. Okay, so moving on, and that's what I was explaining here just a second ago. So here, just to kind of illustrate what this means. All right, so again, let's say we have some fictional matrix A, and let's say that matrix A is 3 by 3. Well, let's say that matrix B is still a 2 by 3 matrix. If we say A times B, if we compare the two sizes of the matrices next to each other, 3 by 3 and a 2 by 3, because these two numbers, the column of matrix A and the row of matrix B, because these are different numbers, these say that we can't multiply the matrices together. Okay, that's what that statement is saying. So now what we're going to do is we're going to take a look at a couple of these. Now before we get started, I will forewarn you, give yourself plenty of space to work these out, because they can eat up a lot of room. Not so much if you're multiplying 2 by 2 matrices together, or something that would produce a 2 by 2 matrix, but some of them can get a little lengthy. Okay, so make sure you're giving yourself enough room when you start working these problems out. So looking here, we have 3 matrices, A, B, and C. All right, what I'm going to do first, very first thing I like to do whenever I'm looking at these, because the size of the matrix kind of tells me whether I can add things together and now multiply things together, it makes sense to, well, what are the size of the matrices? Well, matrix A is a 2 by 2 matrix because it has 2 rows and 2 columns. Matrix B is a 3 by 2 matrix because it has 3 rows and 2 columns. And matrix C is a 3 by 3 matrix, obviously because it has 3 rows and 3 columns. Now we're going to look at the same 3 matrices for a variety of problems. What we see here are just the first 2. So looking at, A, where we're going to say matrix A times matrix B. Well, matrix A is a 2 by 2 matrix, and I'm going to put matrix B next to it, the size of it anyway, and that is a 3 by 2 matrix. So I'm looking at the two interior numbers, the column of row of matrix A and the row number of matrix B. Because these aren't the same, because these two matrices, the column and row number of the respective matrices don't match, that means we cannot multiply them together. So there's your answer. Not possible, not applicable, no way, Jose, however you want to say it. It's not going to happen. All right, so now let's look at matrix C and B for our next example. Okay. So again, what I'm going to do is I'm going to compare first what are the sizes of them. So matrix C is a 3 by 3 matrix, and matrix B is a 3 by 2 matrix. So these, because they're the same, this says, yes, we can multiply them together. The outer numbers, the 3 and the 2 of the outside numbers, says that the product, my answer, that tells me that the answer, the matrix that I get as my solution, is going to have a matrix that is a 3 by 2. All right, so let's go ahead and start writing the matrices out. Since we're going to do some matrix multiplication, let's put them next to each other. So we're going to write matrix C first because we have to put these in the same order that they're put in. That, again, you don't have to think too much about what the commutative property means, but we do have to do these in the order that we see them. That's all you really need to know. So matrix C is the first row 2, -1, and a 2. Next row is 0, 3, and 0. And the last row is 1, 4, and 3. And so here's matrix C. And now I'm going to put matrix B right next to it, which is, let me fix that bracket a little bit. Make them the same size because they do have the same number of rows. So here we're going to say 3, 0, -2, 1, and 5, and 2. Now this is where the similarity of addition and multiplication kind of go together, because what we're going to do is we're going to look at the number of rows in matrix C, and we're going to multiply those to the columns in matrix B. So now what we're going to take a look at is, okay, so we're going to take the first, now this is where I say make sure you give yourself a little bit of space, because we're going to ultimately kind of make one big matrix and then simplify everything inside of it. So what I'm going to do is I'm going to say take everything in, let me try and, I'm going to have to, I don't want to do too much erasing here, but basically what we're going to do is we're going to first start off with by saying take this row and multiply it to this column, and then we'll do the same thing to the next column. So let me kind of explain what we're going to do here. This is known as a product sum operation, meaning that we're going to multiply some things together at the same time as we're adding them. So let me demonstrate what that means. I'm going to start by taking the first element in matrix C, the 2. I'm going to say 2 times the first element of matrix B, which is a 3. And now I'm going to say plus. So this is what I mean when I say product sum, because 2 times 3 is obviously a product, but we're still going to add things to it. Now I'm going to take the middle number of the row, which is a -1, and I'm going to multiply it to the middle number of the column, -2. And I have one more number in my first row, so I'm going to do that as well. So I'm going to say plus the last number here, which is another 2, the last number in the first row, and we're going to multiply it to the last number in the first column of the other matrix, which is a 5. Okay, now all of that is going to simplify to be a single number, and whatever that number is going to be the first element of my final matrix. So now what we're going to do is, let me maybe pick a different color here so we can see. Now I'm going to take the same row, and now I'm going to look at the next column, and I'm going to do the same process. This is the a sum product operation that we're doing here. So again, I'm going to take the first number in the row that we're looking at, and we're not going to have anything in between because we're making a new, this is a new element of a matrix, so we're not going to have anything between here. So I have a 2, and it's going to be multiplied to the 0 there. Then I'm going to say same kind of thing that we did a second ago. -1 times the next number in the column, which is a +1. And then we're going to add the next one, which would be a +2, the last number in the row, multiplied by the last number in the column, which is a +2. Okay, and we're quickly running out of room here, so I'm going to try and squeeze everything in so that way we can, make it work. But actually, no, we're good. All right, so now we're going to go to the next row and kind of, repeat the process here. Okay, so this row is going to get multiplied to the first column of the next matrix, and it's going to, you can see how this is going to start to become a rather tedious process here, but this is what we have to do if we're doing this stuff by hand. So I'm going to take the first number of the second row and multiply it to the first number of the column that we see in the other matrix, which is a 3. And we're going to do the same thing. So sum product operations. So the next row, or the next number in the row here that we're looking at, is a 3. And that's going to get multiplied to the next number of the first column, which is a -2. And finally, the last number of the second row of the matrix C here is going to be another 0, and that is going to get multiplied to the last number in the column, which is a 5. All right, and now we're going to do the same thing one more time with take that same row again, but do the same process with the other column in the matrix. So I'm going to say the first number in the row is 0, which is going to get multiplied to the first number in the second column, which is a 0. And add, and now we're going to say 3 times the next number in the column, which is a 1, and then add, and then the last number in the row multiplied by the last number of the second column, which is a 2, and there we go. So this is kind of where the end of our matrix is going to be. Now if you notice, looking at what we have so far, going across the top row, we have a 2, a -1, and a 2, which matches the rows of matrix C. And looking top to bottom from the columns, we have, like, kind of on the left side of the matrix that we're working on now, we have going down a 3, a -2, and a 5. And so that should kind of match up with the columns that we're working with. And you'll start to see the patterns emerging, and it'll help show you what we're going to be writing out as we do these. But last one that we're going to look at, I'm going to not try to circle anything here. We're looking at the last row of the first matrix, which is a 1. So the first number in that row gets multiplied to the first number of the first column, which is a 3 again. Okay, so you see how those 3's kind of line up in that column? That should always see a pattern emerging like that. All right, so now we're going to take the second number of the last row there, which is a 4, and it'll get multiplied to the next number, which is a -2, and add, and the last number of the third row is a 3, and that's going to get multiplied to the last number of the first column, which is a 5. So you can see the columns of the 3's, the -2's, and the 5's. It's a 5 there. Okay, so that is kind of what you want to see. So now let's take the same row and multiply it to the other column of the second matrix. So again, we're going to start with the 1 and multiply that to the first number in that column, which is a 0. And again, you see the column of zeros here. That's what you want to see. And so now add. So the next number in the row, 4, times the next number in the column, 1, add, and then the last number in the row times the last number in the column, 2. Now this is where we definitely want a calculator to help us with some operations. Type them in exactly as you see. Now this is the process, like I said, is really, it is a little tedious, but it's not challenging. What's really going to be challenging is make sure that you keep track of all your signs and put your numbers in your calculators properly. Okay, so if you multiply, and let me just kind of color code one more time just so you can kind of see what I'm looking at here. All right, what we're going to do now, this sum and product here, all of this is going to create row 1, column 1, that first entry of my answer. Okay, so my final answer, like I said, should be something that has 3 rows and 2 columns. So if I say 2 times 3 plus -1 times -2 plus 2 times 5, all of that is going to give me an 18. Okay, so that's where that number is coming from, and we'll go to the next set of numbers. So in that row, so 2 times 0 plus -1 times 1 plus 2 times 2, all of that is going to give me a 3. Let me keep my same color here. All right, and we're just going to do each individual kind of row there. So 0 times 3 plus 3 times -2 plus 0 times 5. Well, that's just a -6 and so on. So the next one will have another +3 and a 10 and a 10. So all of that work to produce that one 3x2 matrix that we see as our answer. All right. Now, if we had to multiply a 3x3 matrix, you can see that those are actually going to get even bigger. They take up almost like from one side of the page to the other if you kind of write it out like that. So make sure you give yourself plenty of space when you're working these guys out. So let's take a look at our next example. So the matrices didn't change. So now, but now we're going to look at B times A. All right, so B times A. Now let me write these out here again. This is 2 by 2, a 3 by 2, and 3 by 3. All right, so matrix B is a 3 by 2 matrix, and matrix A is a 2 by 2 matrix. So since these two interior numbers are the same, that means we can multiply them together. These two exterior numbers tell me that the product is going to be another 3 by 2 matrix. Okay, so let's go ahead and start working it out and see what we get. So hopefully we can go through this one just a little bit quicker. So matrix B, 3, 0, -2, 1, 5, 2. So here's matrix B. Again, make sure you write the matrices in the order that we're actually having written down for our multiplication. So since B is first, we have to put B on the left side. So now let's do matrix A, which is a 2 by 2 matrix, 2, -1, 1, and 3. Okay, so we're multiplying these two guys together. So again, we're going to kind of do the same thing. I'm going to look at this row multiplied to this column first. Okay, so the first number in the row gets multiplied to the first number in the column and so on. So I will say 3 times 2 as a sum product operation here. And so the next number is a 0 times a 1. All right, so this one's not going to be quite as onerous as the last one was, I don't think. So now we're going to go through the next row here and see what we get. All right, so again, this is where I'll color code this one for the last time, hopefully. So now we're going to look at this as same row gets multiplied to that column now, the second column. So that is what's going to produce the second number in my final matrix out of that first row. So here we're going to say 3 times the -1 that's there, and then plus 0 times the 3. That's the second number in the column. And now we're going to do the same thing with the next row. So the first number of the next row is -2, which will get multiplied to the first number of the first column, which is again is a 2. And you can see up and down the 2's are lining up, which is kind of what you need to see. Now the next number is 1 times the next number of the column, which is another 1. And then we'll do the same thing again. -2 times the second column here will give me a -1. And again, top to bottom, they're matching, which is kind of what we want to see. And so finally, we're going to say +1 multiplied by the 3. And we got one more row to do. So the first number of the last row is a 5, which will get multiplied by a 2 again. And then the last number of the last row is a 2, which will get multiplied to a 1 again. And then the last number of the last operation that will produce our last element, now we're going to say 5 times a -1 now, plus the 2 times the 3 again. Okay, so going across, you should, looking at the rows, you should see all of the row numbers going across that were in the matrix on the left, and the matrix on the right, looking at top to bottom, the 2's, the 1's, the -1's, the 3's, all those should line up in columns there. So again, now make sure you have your calculator handy. Type these guys into your calculator. So the 3 times the 2 plus the 0 times the 1, well, that's going to give me a 6 as the first element of the final matrix of our product. And then you say 3 times -1 plus 0 times 3. Well, that's just -3. So that's the next number in our first row. And just kind of go through the last ones here. And so do the next one, and I'm going to get a -3 here, and then a +5 here, a 12 here, and then finally a 1 here. So here is our happy answer. Okay, that would be the product of matrix B times matrix A. So let's see what we can do about our last one here, B times C. So B, and let me go ahead and pick a completely different color here, so that way they're not all blending together. So let's look at B times C. Well, matrix B is a 3 by 2 matrix, and matrix C is a 3 by 3 matrix. And looking here, that means these can't be multiplied. So we're pretty much done as far as our operations are concerned, because we can't do any. So as we look at these again, like say for instance I had another matrix D that was 3 by 3. If I wanted to multiply those together, that's where it's really going to kind of eat up a lot of real estate on our papers when we're working them out. But that is essentially how we're going to do matrix multiplication. We're going to look at the rows of one matrix and the columns of another matrix, and we're going to perform a product sum operation where I multiply the elements of the rows to the elements of the columns of each matrix and kind of add everything together, and that will produce ultimately the product of our matrix. So again, any questions that you've had or thoughts that you've thought about, make sure you have them written down, bring them in class or in tutoring, and we'll address them then. But in the meantime, thanks for watching everybody, and we will see you later.